हेलो स्टूडेंट्स, वेलकम टू दी बोरिंग स्कूल, जहां हम केमिस्ट्री को याद नहीं करते बल्कि समझते हैं। और आज हम आए हैं इस ब्रिज कोर्स के पार्ट 3 में, जहां हम आज कुछ और नया और इंटरेस्टिंग समझने वाले हैं। तो चलिए, लेट्स अनलॉक द मिस्ट्री बिहाइंड द केमिस्ट्री ऑफ बेसिक concepts, or you can say mole concepts. Now, suppose I have given you a balloon which is filled with oxygen. Now, if I ask you that what is the moles of molecules of O2 which is present in the balloon, then will you be able to find it? Or if I ask you that how many molecules of O2 are present in the balloon, will you be able to find it? Sounds impossible, right? But in chemistry, there's a simple way by which we can calculate the moles of O2 or amount of O2 which is present in the balloon, or the number of molecules which are present in the balloon. And today we are going to discuss that concept itself. So our today's topic is calculation of mole when the volume of gas at a given condition is given. So we have one equation which is applicable for the gases, or more specifically it is applicable for ideal gases, and that equation is known as ideal gas equation. So let me write ideal gas equation. So we have ideal gas equation. Now the derivation of this ideal gas equation in more detail we'll study in another chapter, which is known as gas state. So over here I am directly giving you the equation, which is PV equal to nRT. Many of you might have heard about this equation, that PV is equal to nRT, because it is very common equation. Those who have not studied in detail, they might be hearing it for the first time. So let me explain what are these terms. Here P stands for pressure. P stands for pressure exerted by the gas. P stands for pressure exerted by the gas. V stands for volume of the gas. Volume of the gas, and we know the volume occupied by the gas is equal to volume of the container. So we can also write it as volume of container in which gas is present. Volume of container in which gas is present. And over here represents the number of moles of gas. So N is number of moles of gas, and T represents the absolute temperature. T represents the absolute temperature. And R over here is universal gas constant. R is universal gas constant. And the value of universal gas constant is 0.0821 liter atm per mole Kelvin. Liter atm per mole Kelvin. That is the unit of universal gas constant. Now, with the help of pressure, volume and temperature, we can easily calculate the number of moles of gas. So I can write using this equation that N will be equal to P into V upon R into T. So this will be the formula to calculate the number of moles of any gas. Now, if I'm having any specific condition, like in chemistry we talk about STP condition. So let's first understand what is STP condition. STP stands for standard temperature and pressure. Standard temperature and pressure. STP condition stands for standard temperature and pressure. So at STP condition, temperature is equal to 0 degree centigrade, which is equal to 73.15 Kelvin, and pressure is equal to 1 atm. This is the pressure and temperature at STP condition. And if I substitute over here, then we will find that 1 mole of any gas occupies 22.4 liter. Like if I'm having 1 mole of gas present at STP condition, then it will occupy 22.4 liter. Now, if I change the pressure to 1 bar, if pressure is equal to 1 bar, then we can write 1 mole of any gas, 1 mole of any gas occupies 22.7 liter. So this is the STP condition. Generally we take at 1 atm pressure and 273.15 Kelvin. So in that condition volume will be 22.4 liter, and if I'm taking pressure as 1 bar, then the volume of 1 mole of gas will be equal to 22.7 liters. So this is about the volume occupied by the gas at STP condition. Now let's say I have 2 moles of CO2 gas at STP. We have 2 moles of CO2 gas at STP. We have to find the volume occupied by the gas. Find the volume occupied by the gas. So we know that 1 mole of any gas occupies 22.4 liter. So we know 1 mole of gas occupies 22.4 liter. So 2 mole of gas will occupy 2 into 22.4 liter. 2 mole of gas will occupy 2 into 22.4 liters. That will be equal to 44.8 liter. So if you know number of moles of gas, we can easily find the volume of gas at STP condition. So from here we can write also that volume of gas at STP in which unit? Liters. That is equal to 2 into 22.4. 2 is what? Number of moles of gas. So I can write is equal to number of moles of gas into 22.4. So from here we'll get a formula to calculate number of moles. So we can write number of moles of gas is equal to volume of gas at STP in liters divided by 22.4. Number of moles of gas is equal to volume of gas at STP divided by 22.4. So this is how we calculate the number of moles of gas if the volume of gas is given at STP. Now, one very common mistake. The very common mistake is first that people start applying it for any general condition. So this formula is applicable only and only if the volume of gas is given at STP condition, that is standard temperature and pressure, not at all condition. And second mistake is that they start applying it for liquids and solids. This is not applicable for liquids and solids. It is only and only applicable for gases at STP. So these are two very common mistakes which people make while using this formula. Now let's see some more question based on this. Question: find the moles of gas, which occupies 5.6 liter at STP. Find the moles of gas which occupies 5.6 liter at STP. Now let's see the solution. Now I hope all of you are trying these questions by yourself, and if you have not subscribed my channel, then subscribe it now. Hit the bell icon so that you get notified about all the videos which I am uploading. So question is, we have to find the moles of gas. So we know the formula that number of moles of gas is equal to volume occupied by gas at STP upon 22.4. So that will be equal to, this volume has to be in liters. So it is 5.6 divided by 22.4, which is equal to 1 by 4. So 1 by 4 or 0.25 moles of gas will occupy 5.6 liter at STP. So we have seen three methods. We have seen three methods to calculate the number of moles. First one was when the number of entities was given. So over there I have told you that number of moles of entities will be equal to number of entities divided by Avogadro number. Second formula we have done when weight of a species was given. So in that case, number of moles was equal to given weight of a species in grams divided by molar mass. And today we have discussed the third formula to calculate number of moles when volume of gas is given at STP, which is equal to volume of gas at STP in liter divided by 22.4. Now we'll combine these three using a Y map. We'll combine these three using a Y map to show you what type of questions they ask in the examination. Now this side I'm writing number of entities. This side I'm writing number of entities. Over here I'm writing mass of entities. Mass of entities. Unit will be gram. Next one will be moles of entities. Moles of entities. I have told you in the first class what is entity. So entity can be anything. It can be anything which is involved in the calculation. And last one will be volume of gas in liter at STP condition. Volume of gas in liter at STP condition. Okay. So from moles of entities, how can we find mass of entity? So moles into molar mass we have done was equal to mass of entity. And from mass of entity, how can you find moles of entity? So that was given mass divided by molar mass. Okay. Then we have discussed that from number of entities, how can we calculate moles of entities? So given number of entities divided by Avogadro number will give us moles of entities. And from moles, how can you find number of entities? So moles of entities into Avogadro number will give us number of entities. Same way, from moles of entities, how can we find volume of entities? So it is into 22.4. And from volume of entities, if you want to find moles of entities, so that will be divided by 22.4. So these are the ways by which we can convert mole to number of entities, weight of entities and volume of gas at STP. Now what type of question they will ask? So in exam they can give you number of entities. They can give you number of entities and they can ask what will be mass. Or they can give volume of gas at STP, and they can ask what is the number of gas molecules or what is the weight of gas molecules, like I have asked in the beginning of this lecture. So how will we relate? So suppose they have given volume of gas at STP. Suppose volume of gas at STP is given and they're asking number of entities. So how will you approach? So from volume of gas, first we have to follow this. First you have to find moles of entities. And from moles of entity we can find what? We can find number of entities. Let's take a question. Question is, find the number of CO2 molecules which occupies 11.2 liter at STP. Find the number of molecules of CO2 which occupies 11.2 liter at STP. So in this question, volume is given at STP condition and they're asking what is the number of molecules. So how will you solve? So the approach will be using the Y map, which says from volume, first I have to calculate number of moles, and from moles we can calculate number of molecules. So volume given is 11.2 liter. So from volume, how can we calculate moles? So divided by 22.4. So that will become 1 by 2 moles. And from moles, how can you find number? So that is multiplied by Avogadro number. So number of molecules will be Na by 2. So this is very simple, and this type of question only they asked in JEE Mains, that if volume is given, what will be number of molecules? If number of molecules is given, what will be the weight? What will be the volume occupied by the gas? Let's take one more question. Question is, find the weight of Na by 4 molecules of CO2. So in this number is given. So we can see by map that if number of entity is given and they're asking mass of entity. So how will you approach? From number of entities, you have to find the moles of entities first, and then from moles of entities we can find mass of entities. So let's try this question. So they have given number of entities, number of CO2 molecules. From this we can find moles of CO2 molecule, and from moles of CO2 molecule we can find weight of CO2 molecule. Chalo, let's try this question. So this is Na by 4. From number of molecules, how can we calculate moles? So it is by dividing it by Avogadro number. So if we divide it by Avogadro number, we'll get 1 by 4. So 1 by 4 moles of CO2 is present. And from moles, how can we find weight? So for that, we have to multiply by its molar mass. So 1 by 4 into molar mass of CO2 is 44. That will be equal to 11 gram. So answer for this question will be 11 gram. So this is very simple if you remember the Y map. The interconversion from number of entities to mass of entities, volume of gas at STP, or from mass of entities to number of entities or volume of gas at STP, or from volume of gas at STP to number of entities and weight of entities will be very, very simple. So chemistry is not about only learning. After learning the concept, you should practice the questions from your reference book which you have taken. And if you have any doubt, you can drop a comment down, and I will respond to your comment by giving you a detailed solution of that particular question. So I hope everything is clear to all of you. All the 3 formulas which you have done for the calculation of moles is very clear, and you keep practicing all those questions. In the coming video, I'll bring the concept of stoichiometry for you, from which the real exam questions are asked. So till then, keep practicing. See you in next video. Thank you.